Dear students, today we are continuing waves, in which we will study today transverse and longitudinal waves. A mechanical wave to be transverse or longitudinal type depends upon direction of disturbance and wave propagation. It means in transverse waves, disturbance travels perpendicular to wave propagation, whereas in longitudinal waves, disturbance travel along the direction of wave propagation. Let us consider an example to understand transverse and longitudinal waves. Longitudinal wave. First we will take the transverse wave. First we will take an example for transverse wave. Consider a string attached at one end with rigid support. When a single up and down jerk is provided to string, a pulse travel along the string as shown in the figure below. The formation and propagation of pulse appears because of tension in string and distortion in the shape of string. Distortion in the shape of string, which means pulse moves along the string with certain velocity. Moves along the string with certain velocity, which is v, which is v, velocity v, as continuous up and down jerks are provided to string. A continuous wave travels along a string. One thing is here to remember, the shape of wave in a string will be according to shape of jerks provided to string. We can see here by the figure drawn below how a pulse travels through the string. We have seen in the diagram shown above that every string element is placed with respect to its mean position, that is called the displacement or vibration of string element along vertical axis. Thus, the vibration of string elements is perpendicular to, means transverse to, the direction of traveling of wave. Such a wave is called transverse wave, where string elements regain their respective positions on horizontal axis after transporting the disturbance to the next elements of string. So that's all for today for transverse waves. We will take the example for longitudinal wave on next chapter.